And for homogeneous ODE, you're looking to see that if you have fractions, you have the same degree in the numerator and the denominator. If you have polynomials, each polynomial term has the same degree. With a Bernoulli ODE, you can make one of two substitutions. You can either let v equal x over y, or you can let v equal y over x. Either one should work. Sometimes one is easier to use than the other. But definitely if you see that you have x over y terms, that's what you want to use. And so here I want to substitute in for my x over y, that's going to be v, and I need to know what dy dx is. So let me solve for y. If I solve for y, I'm going to get y equals x, I'm going to write it this way, times v to the negative first. You get x over v. And then dy dx is, here I need to use the product rule. When I take the derivative of x with respect to x, I get 1 times v to the negative first. So when I take the derivative of v to the negative first, I get negative 1 v to the negative second times dv dx, and then that's multiplied by x. Okay, so substituting in dy dx, I'm going to write this as negative x v to the negative second dv dx, negative x v to the negative second dv dx is equal to x over y is equal to v. And this should change the equation to one that's separable. So here I want to separate the variables. I'm going to multiply both sides by dx to get dx out of the denominator. That tells me my x terms are going to be on the right side. So I need to divide by v, and I need to divide by x. And that's going to give me, let me change the color. That's going to give me negative, see, dividing by v is going to subtract one more. It's going to give me negative v to the negative third dv equals 1 over x dx. From here I can integrate both sides. On the left side, let's see, I have negative v, increasing the exponent by 1 gives me a negative 2. Divide by negative 2 equals, on the right side, when you integrate 1 over x, you get natural log of x, and then plus c. And I want to try and simplify this. I'm going to multiply by 2 first, so that I get v to the negative second equals 2 natural log of x plus 2c. And then I'm going to substitute in v is x over y, so v to the negative second, that's going to take the reciprocal of it, y over x, and square it. You're going to get y squared over x squared. Let me write that, y squared over x squared is equal to 2 natural log x plus 2c, and you can isolate the y squared term. Actually, this is an initial value problem, so I'm going to need more room. Let me go up here. So that's going to give me y squared equals, I'm multiplying here by x squared to get 2x squared natural log of x plus 2c x squared. Okay, now if I solved for y, I would get y is equal to plus or minus the square root of the right side. And if I look at my initial value, I know that y of 0, when x is 0, I get a negative value for y. So when I take the square root property to solve for y, I want to consider only the negative square root. That way when x is 0, I'm going to get a negative y. For the general solution, you actually do get two answers. You get plus or minus. But for this particular solution, because we're given the initial value, we want to look to see where that point is, and this point is on the negative side. Now to solve for c, x is 0, y is negative 2. Y of 0 is negative 2, gives me negative square root actually that's undefined. X can't be 0 because x is the argument of the natural log. So this is undefined. You know, I bet you that this should have been y of 1. Let me change that to y of 1 to show you how you get your solution. At 0, there's no solution. Y of 0 equals negative 2, no solution. Because you can't take the natural log of 0. But I promise on a test I won't give you one that says no solution. So let's make that a 1. I'll go back and change it on the practice test also. Y of 1 equals negative 2. Putting 1 in for your x, you're going to get negative 2 times 1 times natural log of 1 is 0 plus 2c times 1. Here multiplying through by a negative gives you 2 equals the square root of 2c. Square both sides. Get 4 is equal to 2c. Divide by 2. You get 2 is equal to c. So c is 2. And your particular solution is going to be y equals negative square root of negative 2x squared natural log x plus 2 times 2 is 4x squared.